Hello everybody, welcome back. In this session, I want to talk about two common problems in training a model, overfit and underfit. But before that, I want to talk about alpha that we used in gradient descent formula previous session. As you remember, gradient descent is one of the most common optimization algorithms, and this is its formula, which has an alpha. But what does alpha do? Alpha is one of the most important parameters in your model that you have to find an optimal value for that. Alpha is our learning rate, and what it does is that it controls the size of our steps to get to the bottom point and minimize our loss. The larger the alpha, the greater our step size. For example, if alpha equals to 0.1, then our steps will be larger than the time that alpha is equal to 0.01. But what will happen if our learning rate is too small or too large? Can we use a very large alpha and have huge steps to get to the bottom very fast? The answer is no. If alpha is too large, you spend all your time bounding around the lost landscape and never actually descending to the bottom of the bowl. Conversely, if alpha is too small, then it will take too many iterations to reach to the bottom of the bowl. And this means it takes a really long time to reach to the bottom, so it's extremely slow. As I told you, you have to find an optimal value for alpha. Of course, finding a suitable size for our steps is not that easy. But here's a tip. To choose suitable size, try these values. You will try different values for alpha when we start to code. If you don't know Python, watch our Python tutorial in this channel. It will give you everything from the beginning. Now it's time to talk about overfit and underfit. As you know, we were trying to find the best line that can cover our training data well and learn from that so it can predict the results of any other data with high accuracy. There's a chance that your model can predict the answers of your training data very well because it has seen these data before, but it fails to predict the results of new data. And that's what we call overfit. On the other hand, we can have a line that has no curvature and it's too simple to even fit on our training data. In other words, its formula is a simple linear combination. Look at this diagram. In this diagram, you can see three lines with different curvatures. Blue line tries to focus on just training data, which are dark red points. And purple line is too simple to cover data. So both of them are unsuccessful and cannot cover new data. Although the green one is not fit exactly on training data, it can find a general range that can cover most of the data. Doesn't matter if it is new or it's from our training data. So if the focus is only on our training data, model works well on data that it has seen before, but fails to predict the result for new data. And this is what we call overfit. So both of them are unsuccessful and cannot cover new data. Although the green one is not fit exactly on training data, it can find a general range that can cover most of the data. Doesn't matter if it's new or it's from our training data. So if the focus is only on our training data, model works well on data it has seen before, but fails to predict the results for new data that it hasn't seen before. And this is what we call overfit. And I told you that if our line is too simple, like purple one, it will be useless either. So we have to find a line that can learn well and works on new data, just like the green one. Next session, we will talk about solutions to overfit and underfit. That is really important and you definitely will need them to optimize a model. If you don't know Python, I strongly suggest you to start watching our Python tutorial videos in this channel so that you don't get into any trouble when we start to code deep learning in Python. If you haven't subscribed yet, please subscribe our channel. and turn on the notification bell so whenever I publish a video, you will be notified.